Okay, let's look at problem 2.4, where we have these ferries and boats and things going on. The first thing you need to do, like with all these things, is draw a really good picture. And the problems that you turn in, take pictures of, you should draw a really good picture. Draw this picture there. You don't need to put all these lines, and you don't even need Ballard. I think later on there's a problem where they're going to include Ballard or something. Right now, all we care about are these three things. So we can ignore all this stuff down there. Not a hard picture to draw. Label everything really clearly. Okay, so I can cheat and put it up here. So again, it's nice to keep everything positive, keeping everything in the first quadrant. So to do that, we want to make Kingston then the origin. So we make our axis like this, right? So Kingston is the origin. And then we can put numbers and everything is positive. So if we do that, then it says that he is the sailboat, which is, sailboat right there is 3 miles east and 2 miles north. Okay, so this is 3 and this is 2. So the coordinates of the sailboat are, this is the x coordinate first, 3, 2. And then we can also label what's happening. The ferry leaves Kingston heading due east towards Edmonds at 12 miles per hour. So the ferry goes this way at 12 miles per hour. And we also know that at the same time, which is nice, it's the same time, Eric leaves the sailboat in a dinghy heading due south at 10 feet per second. So part A, now it's just practicing like in chapter 1, converting units. You got to change 10 feet per second to miles per hour. And then the rest of the problem, it kind of makes sense to use miles and hours because they already give stuff in miles and we have 12 miles per hour. So we'll change his speed, the sailboat, to miles per hour. And I'll let you guys do that. You should be able to do that easily. And the answers they got, I'll just use their answer. They got that he was going 6.818 miles per hour. So the sailboat then is going this way. Let's see. Where can I write that? Oh, I'll put it up here. Sailboat's going downwards at 6.818 miles per hour. Okay, so are they going to crash into each other? What's going to happen? So then they say, fill out this table. And okay, one really confusing thing is the table and the answers, they give the columns as rows. So yeah, that's kind of weird. So, but then they just say the distance between the two things, right? What is the distance between them? Yeah, so, and again, just be careful with the answers, and I think you can fill out the table pretty well. But, and the tricky part is the distance between at time t, right? What is the distance between them when the time is just some random time? So let's see. When they start out, right, the distance between them is, here's the ferry, there's the sailboat, it's that distance d, and so d is just the square root of 3 squared plus 2 squared. So if you fill out the table in the beginning, at 0 seconds, and I hope I don't mess this up, so 0 seconds, the distance between them is the square root of 3 squared plus 2 squared. Doesn't matter what the time is because time is 0. So it's a nice simple answer there. And again, you can fill out the other ones on your own. And then, let's see. It's really confusing how they get, they get 3.606. Again, the answers they give are opposite of the table. It's really confusing. But I think you get 3.606 or something if you do that. I'll let you guys figure that out. And then in 30 seconds, 7 minutes, 1 hour, right, what are the distances? So let's see. In 30 seconds, then we're going to have a new d here. Then maybe the boat is somewhere right in here, and it goes to somewhere right there. Right, so here's our new d. So what is, we have a new triangle. So, and this works the same until they pass each other up. So let's see, in 30 seconds or something like that. So let's see, this D here is 2 miles minus the distance they've traveled. Right? So this distance here, and this is where drawing a picture is really important. That distance, wait, I want to put it like this. That distance there is 3 minus this distance, which is how far he's traveled, which is this speed, so 6.818 times the time, and again, time will be in hours. So, because this is the distance he's traveled, velocity times time, 6.818 t, and so that's 3, so that distance, yes, is 3 minus that. And this distance here, oh wait, it's 2, right? 2 minus that, I'm getting my 2's and 3's mixed up. 2 minus that distance is 2, yes. This one here is the opposite. This one is, the distance there is 3 minus the distance the boats traveled. So that distance there is 3 minus 12t. Yes, I think that looks right. And now we have to have so our total distance now, we have to put the t's in. The total distance now is the square root of this squared plus that squared. 2 minus 6.818t squared plus 3 minus 12t squared. And you plug in for t. Be really careful, 30 seconds is not very much of an hour, right? It's half of a minute, so what, 1/20th hour? So in this case, t would be 1/20th of an hour. Let's see, yeah, 1 minute's 1/60th hour. So half of that would be 1/20th of an hour. You do the same thing for 7 minutes. In 7 minutes, that's 7/60ths. You plug in 7/60ths for t, but that, I believe, is how you would do that. You can break it up into steps, but that's the basic idea, right? You want to know how far away they are between each other. Okay, then how about in 1 hour? In 1 hour, those boats moved 12 miles. So 12 miles is way over here somewhere, and way more than 3 miles, right? And in 1 hour, he's gone 6.18818, so he's way down here. So you have to draw a whole new picture. How far is Kingston? How far is Edmonds? Edmonds is, well, I guess we don't really care. Edmonds is really far away, so I guess in 1 hour it should be 12 miles away. So this guy over here is 12 miles over here in 1 hour, so it would be 9 past that place. So you have to draw a new picture for that one. Because, all right, it's 9 this way, and the boat would be 6.18 down. Okay, you guys can figure that one out. Now, finally, C, explain why Eric misses the ferry. So we want to know when Eric is right here, okay, how long does it take Eric to get right there? Or basically we want to know, when is this distance, is that distance ever 0? Can that distance ever be 0? That's kind of the same thing, right? Will they ever collide? Will that time ever be 0? Is there a t that makes that 0? Or we could just figure out, when Eric is here, where is the ferry, right? So are they going to catch the ferry? So we can figure that the distance there is 2 miles. So how long does it take Eric to go 2 miles? So his time is speed. This pen needs to get done. So the time for Eric is the distance divided by his velocity. He's got 2 miles due south to go, divided by 6.818. So that's time for Eric. The time for the ferry to get right there, the ferry has 3 miles to go, divided by 12 miles per hour. Okay, I can do that in my head. That's 1/4 hours, 15 minutes, and 2 divided by 6,818 is going to be less than that, or more than that. No, we'll see. So 2 divided by 6.818, I get 0.2933. So more than that. So 0.2933 hours, and this is 0.25 hours. So the ferry gets there first, and then the ferry is going to be right over here. So when Eric gets there, a little while later. So clearly Eric's going to miss the ferry. In other words, there is no time in here that you can make where this is going to be 0. Which kind of makes sense too, right? Is there a t? What t can make this 0 and that 0 at the same time? Pretty much impossible. We could have just looked at that. Well, it is impossible. Okay, after 10 minutes, Coast Guard boat leaves Kingston heading due east at a speed of 25 feet per second. Will the Coast Guard boat catch the ferry before it reaches Edmonds? Explain. Okay, after 10 minutes, Coast Guard boat leaves Kingston heading due east at the speed of 25. Okay, so due east is this way. Wait. Leaves... Let me figure this out. Leaves Kingston. Coast Guard boat leaves Kingston heading due east. Okay, 25 feet per second. We're at catch the ferry. Okay, so we got to change 25 feet per second to miles per hour. Okay, so let's do that. So we have 25 feet per second. You write it as a fraction. Feet per second times, you want miles per hour. I know that there are 1 mile is the same as 5,280 feet, and 3,600 seconds is the same as 1 hour. So you go 25 times 3,600 divided by that. So let's see. 25 times 3,600 divided by 5,280. And I get 17.045. I better keep lots of decimal places. So 17.045 miles per hour. Okay, so this thing is going to catch. It's going fast, right? So will it catch it before? Will the Coast Guard before it reaches Edmonds? Wait, now how far away is Edmonds? We gotta know that again. Edmonds is 6 miles due east of Kingston. So we gotta know Edmonds is 6 miles. So, okay, that's easy. It takes the ferry 6 miles at 12 miles per hour, half an hour. Right? So 6 miles going 12 miles per hour, it takes it half an hour. So basically we have 30 minutes to catch it. It already lost 8 minutes. It started 8 minutes left. So can it finish this in 22 minutes, which is the same as 22 divided by 60 hours? Can it finish it in 22/60ths of an hour? So let's figure out how long it takes for this thing going that speed to go 6 miles. So the time is distance divided by velocity. It's got to go 6 miles at 17.045 miles per hour. So we go 6 divided by that. And where's my calculator? Here it is. 6 divided by 17.045. I get 0.352 hours. So 0.352 hours. And it leaves 8 minutes late. So 8 minutes is what fraction of an hour? 8 divided by 60. 8 divided by 60 is 0.13333. So we have to add 0.1333 forever hours, because that's the same as 8 minutes. And so let's add that to 0.352 plus 0.352, and I get 0.485. So that's 0.485 hours. So it's going to get all the way to Edmonds in less than half an hour, right? A little tiny bit less than half an hour. So it will catch the ferry, because the ferry takes exactly half an hour to get there. And it's going to, yes, so that boat will catch the ferry. These problems are all about drawing good pictures using distance is velocity is time, distance is velocity times time, time is distance divided by velocity, some basic formulas like that, converting units, feet per second, not getting confused, a little bit of Pythagorean theorem like this here to come up with this formula, and then again labeling things really well, and drawing a picture and thinking, okay, what's this? So it's 3 minus the distance the thing this is gone. A lot of the problems in this chapter are like that, drawing a really good picture and then labeling, drawing your triangles, figuring out if this is part of it and this is the big part. The part left is the big part minus the little part that you've got. Really, really common thing that's going to come up with a lot of problems. So draw big pictures, label things really well. Try not to write on top of other writing. Hopefully you can see what I wrote here. It's kind of a mess, but hopefully you can see that. Yep. Okay. Hopefully all that made sense, and let me know if it doesn't. Okay, thanks.